In this video, we'll go over all of the skills you'll need to know for Unit 7, Systems of Equations. First of all, what are systems of equations? We are looking at two or more functions graphed on the same plane. We're focusing specifically on linear systems, meaning two lines graphed on the same plane. And there's a couple different ways that we can solve them. Here are two lines, 2/3 x plus 3, negative 2x minus 5. Where do they intersect? The answer is right here. That coordinate is negative 3, 1. That's our answer. We can also write that as x is equal to negative 3 and y is equal to 1. When those values are plugged in, they work for both lines. That's the only such point. Most lines cross at exactly one point and have one solution, just like this. You might also have to solve them by graphing, but you have to create the graph yourself. Remember that the negative 5 is our b value. That's like our starting point. So we go down here at minus 5. The 2 is about rise over run. Think of that as 2 over 1. And we go up 2 and right 1. If we wanted to, you could do that pattern a couple of times. Up 2, right 1. And you can also go down 2, left 1 to head in the other direction. There's your line. For the second line, I'm going to start here at plus 5. That tells me that my b value, or my y-intercept, is a positive 5. The line crosses the y-axis at positive 5. From my negative 1/2, that's my rise over run. That means I go down 1, right 2. If I wanted to go the opposite direction, I could go up 1, left 2. Where do these two lines cross? At this point, 4, 3. Or x is 4 and y is 3. If you wanted to do the same process on your graphing calculator, you could take these original equations, plug them into y equals as y1 and y2. If you press the second key and the trace key, it brings up the calculate menu. From there you can choose option 5, which says intersect, and press enter 3 times. It will find the exact point that these two lines cross. The third type of graphing we will have to solve is when at least one of your equations is not given to you in y equals mx plus b form. So here the problem is this equation. And we can't put it in our calculator, and we can't use slope and intercept directly to graph it. What we do is we solve this for y. At that point, we can graph it according to the previous methods. So notice that my intercept is a positive 2, and my slope is negative 3 over 5. That means I go down 3 and right 5. If I wanted to go in the other direction, I could go up 3 and left 5. For my other line, I start here at negative 6. In front of this is a 1. Think of that as 1 over 1. Up 1, right 1. If I draw my two lines, where they cross is right here at 5, negative 1. Or when x is equal to 5 and y is equal to negative 1. The next method of finding where two lines cross is to use substitution. So even though these technically are lines and I could graph them, we can also solve them another way. Because we have two statements that both say y equals something, we can take what y is equal to and plug it in for one of the other ones. Or in other words, we're going to set these two equal to each other. Negative 6x is equal to negative 4x plus 2. This goes back to Unit 1. What do? You have to get all of the x terms on one side of the equation. I'm going to choose the left. This gives me negative 2x is equal to 2. If I divide by a negative 2, I get negative 1. Just like with graphing, we have to find a coordinate, x, y. So how do we find the other one? Well, let's choose either one of our original two equations, 1 or 2. I'm going to choose the first one because it's simpler. And we're going to plug in this value of x. So this becomes negative 6 times negative 1. Or in other words, y is equal to 6. If I put it all together, I have the coordinate negative 1, 6. Sometimes we don't have two statements where it's y equals, but we can still use substitution. What we're looking for is out of all of the coefficients, where do I see a positive 1? This one's not it, not it, not it. This is the one. This equation says y equals something. So what I can do is I can plug that into the other equation. Wherever there's a y, I can replace it with what it's equal to. So I'm going to replace it with 9x. So if I rewrite negative 10x plus 2 is equal to negative 32, instead of putting a y there, I'm going to put a 9x there. Then I solve like we did previously in the course. First we multiply, then we combine like terms, then we divide to find that x is negative 4. To find the answer, I'm going to plug this in to one of my original equations. I'm going to choose the bottom one. 9 times negative 4, because that's 9 times x, is equal to y. Negative 36 is equal to y. My final answer here I can record as negative 4 comma negative 36. This is the coordinate where the two lines cross. This problem's almost identical, but instead of replacing y, we're going to replace x. So I'm going to take that 7y and plug it into the other one. 3 times 7y minus y is equal to negative 40. It's very important to pay attention to which variable you're solving for. For this one, I'm solving for y. Once I combine like terms and divide out the 20, I have y is equal to negative 2. I'm going to plug that back in to one of the original equations, and I have x is equal to 7 times negative 2, or x is equal to negative 14. So make sure that when you write your coordinate, you put your x answer first and then your y answer second. The final type of substitution problem is when we are plugging in an entire expression. So we start here with x is equal to something, and we replace that in the other equation. So this becomes negative 4 times the quantity y plus 5 plus 7y is equal to negative 41. The first thing you have to do is distribute the negative 4 to each term inside of the parentheses. This gives me negative 4y minus 20, and I write everything else exactly as before. When I combine like terms, I have negative 20 plus 3y is equal to negative 41, or 3y is equal to negative 21, or y is equal to negative 7. I can plug that into one of my original equations. So instead of x is equal to y plus 5, it'll be negative 7 plus 5, or x is equal to negative 2. Make sure you write them in the correct order when you are identifying the coordinate. That represents where the two lines cross. The third and final strategy is called elimination. What you are allowed to do if you have your columns set up correctly, x, y, number, is add or subtract all of the columns straight up and down. Why would you do that? Well, sometimes if you add all of the columns, your x's disappear. And that allows you to write that 10y is equal to 20 and find the answer a little bit faster than with substitution. This only works, however, if things are set up correctly. What you are looking for is the same number in a column. For example, here we see 2's. But if we tried to add those, we would get negative 4y instead of 0. So this time we're going to subtract. And if we subtract all three columns, and it gives us 7x is equal to negative 63. How did I get that? Because it's negative 75 minus a negative 12. So that's really like negative 75 plus 12, which brings us closer to 0. And you can solve for x from here and plug it back in to find the other. But one portion of the quiz will just be, should I add or should I subtract? Am I eliminating x or am I eliminating y? Then of course we'll have to actually solve some of these systems. Here, addition is the correct strategy or approach. If I do that, I get 0x, which just goes away. 4 plus a negative 8 is minus 4y, and that gives me negative 8. So this tells me that y is equal to 2. I can plug that back into one of my original equations. Let's try the top one. So 3x plus 4 times 2, since that's what y is equal to negative 7. Or 3x plus 8 is equal to negative 7. Or 3x is equal to negative 15. Or x is equal to negative 5. If I write it as a coordinate, pay close attention to x comma y. That's the order for your coordinate. Sometimes if we try to set up elimination, none of the numbers are the same, and we can't use this trick. unless we decide to multiply one of the equations. So let's say we doubled this bottom equation. You can double the entire thing. The 4x is doubled, the minus y is doubled, and the 6 is doubled. So let's cross this out because now I'm looking at my new equation. It turns out if I subtract all three columns straight down, so I'll subtract this entire thing, I get 0x, I get negative 8y. That's right there I'm looking at negative 10 minus a negative 2. So that's like negative 10 plus 2. That's why I get negative 8y. And then 28 minus 12 is 16. This tells me that y is equal to negative 2. I can plug that back into one of my original equations. Let's say the top one. 8x minus 10 times negative 2 is equal to 28. 8x, and here, since I'm subtracting a negative, this is like minus negative 20 is equal to 28. Or 8x plus 20 is equal to 28. So if I simplify, I get 8x is equal to 8, or x is equal to 1. I can write my answer as 1, negative 2. It's also possible that given a system of equations, they don't match up, and I can't multiply just one of them, because 4 times something doesn't give me 9, and 3 times something doesn't give me 7, and I actually have to multiply both of them. So let's say I chose to multiply the top one by 7, and the bottom one by 3. I'm targeting the y's. This will give me 21y on top, and negative 21y on bottom, which is exactly what I need to use elimination. The rest I still have to multiply according to these rules I have set about. And here I can add all three columns straight down. This will give me that 55x is equal to 55. And the y's are 0 and they go away. So x here is equal to 1. And if I plug that into one of my original equations, I have 4 times 1 plus 3y is equal to 7. Or 3y is equal to 3. So y is also going to be equal to 1. Last up are the how many solution questions. So these involve using elimination, but they can come in different methods, and I'll show you how for all of them. Here, notice that the y coordinates are both 1s. If I add these straight down, I can cancel out my y's, and I get 6x is equal to negative 7. Now if I was actually solving this, it would be kind of obnoxious because I have negative 7/6 here. And then I could try to plug that back in to find the other. But at this point, I know that there's exactly one solution. Here's why. Let's take a look at the other cases. For this one, if we double the top equation, we now have 8x plus 6y is equal to negative 12. Notice that these are identical now. If I was to subtract these straight down, I would get 0x plus 0y is equal to 0. Or in other words, 0 is equal to 0, which is a true statement. For that case, we have infinitely many solutions. And notice here that the x's and the y's are all gone. That's how you know it's an exception. When you're done, if you still have an x or a y, it's always just going to be one solution. Here, if I double the top equation again, I have negative 6x plus 4y is equal to 14. If I add these all straight down, I get 0x plus 0y is equal to negative 1. Or 0 is equal to negative 1, which is a false statement. And the answer is going to be no solutions. When your x's and y's cancel out, it's going to be one of the exceptions. And if it's a true statement, it's infinite. If it's a false statement, it's no solution. Graphically, here are what the exceptions look like. If there's no solution, that means the lines never cross. That's because they have the same slope, but a different intercept. Infinite solutions means both lines are actually the same line. They might look like this. The first one might be 2x plus 6, and the second one is 2 times x plus 3, which if you distribute, gives you 2x plus 6. So it turns out every single point is on both lines because they're actually the same line.